What we learned last time was how to eliminate the arbitrary constant and formulate the differential equation. What is the different here is the methods were different for different type of functions. But what I'm going to teach you is a generalized method, a general method, which you can apply for almost all. We know that when I differentiate a constant alone, my answer is 0. Automatically, the constant get eliminated, provided you're differentiating it without any x or y term. Suppose I was differentiating a with an x term, my answer would have been a would have remained in my answer. So the idea that I'm going to apply here is make a or arbitrary constant independent of x and then differentiate. Let's take an example which I've already done. Let's say e raised to 2x plus b e raised to x. Now what I'll do is I'll make b independent of x. I want to eliminate b. I'll make it b independent of x. What is a function of x with the b? E raised to x. So divide by e raised to x. Now this became e raised to minus x. A, e raised to 2x and e raised to x power subtracted and b. Now you will differentiate this. What happens when you differentiate this? Here you need to apply product rule. So d by dx of y e raised to minus x is a into d by dx of e raised to x plus d by dx of b. Now b is without any x term, so when you differentiate, automatically b gets eliminated. So y into e raised to minus x into minus 1 plus e raised to minus x into dy by dx. What did I do here? I applied the product rule on y and e raised to minus x. A into derivative of e raised to x is e raised to x only. Again, a is with a function. So again divide by e raised to x. So minus y e raised to minus x divided by e raised to x plus e raised to minus x into dy by dx divided by e raised to x is equal to a. Now I can write minus y e raised to minus 2x plus e raised to minus 2x into dy by dx equal to a. For convenience of differentiation, I'll take e raised to minus 2x common and write as dy by dx minus y. Now I'll differentiate this again. Now when you differentiate a, what will happen? How many times I'm allowed to differentiate?
2.
Because there are two arbitrary constants. So first derivative I did, that time b got eliminated. Now second derivative I'm going to do, automatically a will get eliminated. So again product rule I'm applying, e raised to minus 2x, e raised to minus 2x into derivative of dy by dx minus 1. What is the derivative of this? d2y by dx2 minus dy by dx plus dy by dx minus y into derivative of e raised to minus 2x. E raised to minus 2x into minus 2. Right hand side became 0. So automatically a and b got eliminated. Now you can write your answer. In this answer, e raised to minus 2x is common. So if I take e raised to minus 2x common, what is my answer here? Second derivative d2y by dx2 minus dy by dx minus 2 dy by dx minus 3 dy by dx. Y will be plus 2y equal to 0. Now this e raised to minus 2x will go to the denominator of 0 and vanish, and this becomes your answer. So this is how you can make the term independent of x. Like here, whatever the coefficient of b, divide by that and then differentiate. Automatically the arbitrary constant will get eliminated and get the answer. This is a generalized method. So what is a general method? General method, what is general method? Divide. If we want to eliminate, if we want to remove any arbitrary constant, what I should do it, make it independent of x and y terms. Which can be done by dividing the solution by the coefficient of the arbitrary constant. Example, you write y minus a the whole square. Okay, I'll not write this example. This example you will take time. This will take after this. I'll take a simple example. Ax square plus by square equal to 1. I want to eliminate a and b. Okay, method 1. First, I'm planning to eliminate a. If I am planning to eliminate a, what should I do?
Divide by
Divide by how much?
X square.
Divide by what? The coefficient of the arbitrary constant. I wanted to eliminate a. What is the coefficient of a? X square. So divide by
and y square.
No, you cannot divide by both. I am planning to eliminate one by one. So first you have to eliminate a. So divide only by coefficient of a, not by coefficient of b. So what you'll get the answer? A plus, okay, I'll write down. What this function will become? A plus b y square by x square plus 1 by x square is equal to 1 by x square is equal to 1. Now I'll differentiate with respect to x. When you differentiate with respect to x, what will happen? A will go away, b will remain, but I have to apply u upon v method. X square into derivative of the numerator minus numerator into derivative of the denominator upon square of the denominator. And then derivative of 1 by x square, x raised to minus 2 derivative. Minus 2, x raised to minus 3, so minus 2 upon x cube. Is that okay?
Yes, sir.
Now let's see what can be taken common and reduced. So b into x is common and y is common. X and y is taken common. 2 is common. So what is remaining here? X dy by dx. What is common here? What is remaining here? Minus y divided by x raised to 4 equal to minus 2 upon x cube. 2 and 2 got cancelled. X cube and all got cancelled. So what is remaining is b times y into x dy by dx minus y equal to minus 2. Next, I have to make b also independent of x. To make b independent of x, what should I do?
So minus 2 will not be there. We cancel.
Minus 2 also got cancelled, so only minus 1. Minus 1. So tell me, what should I do to make b independent of x?
Divide by x.
Divide by whatever the coefficient of b. What are the coefficient of b? So many terms are there, but that is going to be a little complicated. So what I'll do is, I'll make a little change here. I'll divide by b. Now this is a constant, and it is independent of x. So when I calculate the derivative of this, it will become 0. So now I'll differentiate. So I'll again have to apply product rule. Y into derivative of this again product rule, x d square y by dx square plus dy by dx into 1 minus dy by dx. So y into derivative of u into derivative of y, and right hand side became 0. And now this is my differential equation, or this is my answer. So what happens in next step? This dy by dx and this dy by dx will get cancelled. xy d2y by dx2 plus x dy by dx the whole square minus y dy by dx equal to 0 becomes my answer. Is it clear?
Yes, sir.
Have you written this or not written?
Not written. Yes.
Hello. Yeah. चलेगा थोड़ा time. In method 2, first derivative I'm going to do like that only. Differentiate with respect to x. A into 2x, b into 2y divided by dx equal to 0. Now see what I'm going to do next step. B into 2y divided by dx is minus 2ax. Now look at next step. Y divided by dx upon x is minus a by b. What did I do? Tell me.
To call the constant to one
I
side.
made both a and b independent of x. What will happen next derivative? Both a and b will go. And how many times I'm allowed to differentiate? 2 times.
2.
First derivative, nothing went. But next derivative, both a and b is going to get removed. So now if I differentiate this u by v method, d by dx of y divided by dx upon x equal to 0. So x into derivative of numerator. What is the numerator derivative? Y into d2y by dx2 plus dy by dx into dy by dx. That I'm writing and dy by dx square. So what I did, denominator into derivative of numerator minus numerator into derivative of denominator upon square of the denominator equal to 0. But this will get multiplied with 0. So that will go away. So my answer will be x d2y by dx2 plus x dy by dx the whole square minus y dy by dx equal to 0. This is exactly the answer which I got before. Just check. Is it not the same answer? Is not the same answer I got. So this is very fast method. So what is the difference between method 1 and method 2? Method 1, I was eliminating first a. After eliminating a, I made b independent of x, then differentiated to get. Here what did I do? After the first derivative, both a and b I made independent of x and differentiated so that a and b gets removed. Is it clear?
Yes, sir.
Yes, sir.
This is the equation of the ellipse. What is the equation of the ellipse? X square upon a square, y square upon b square equal to 1. So 1 upon a square is your a, 1 upon b square is your b. So it's an important question. And this method is the best method. Okay, now write down this question. Formulate the differential, obtain the differential equation whose solution is y minus a the whole square is equal to 4 into x minus b. What to do? How many arbitrary constant?
2.
2. How many times I'm allowed to differentiate?
2.
2. So what should I do first step? I am planning to eliminate b. Does b has any coefficient?
No.
No. B is a constant. So when I differentiate, what will happen to b? I hope you are writing with me.
Yes, sir.
D by dx of y minus a the whole square is 4 into d by dx of x minus b. Give me the answer. 2 into y minus a into derivative of y minus a is 2 into 1. 2 and 2 went away. So I got y minus a into dy by dx is 1. Tell me what is the next step.
Sir, it should be 4 on the right hand side.
4 and now 4 it was there, no? 4. Okay. Tell me now. What should I do next step? I want to eliminate a. Speak out here.
Make A as a constant.
Make a as a subject. A should not have any coefficient. What is the coefficient of a here?
Y by
Minus
dx.
What is the coefficient of a here?
Dy by dx.
dy by dx. So what should I do? Divide by dy by dx. If I divide by dy by dx, what will happen? Y minus a is 2 upon dy by dx. Y minus a is 2 times dy by dx raised to minus 1. Now differentiate this. What will be the left hand side? What is the derivative of y?
dy by dx.
dy by dx. Derivative of a. Derivative of dy by dx raised to minus 1. Power rule. What will be the answer?
Minus 1 dy by dx raised to minus 2.
Minus 1 into dy by dx raised to minus 2 into derivative of dy by dx. What do you call derivative of dy by dx?
d2y by dx square.
Dy by dx is equal to minus 2 upon dy by dx the whole square. What did I do? This raised to minus 2, I brought in denominator into the second derivative. Now cross multiply this. Dy by dx the whole cube is minus second derivative. Make it equal to 0. So 2 d2y by dx2 minus dy by dx the whole cube equal to 0 is the required differential equation. Understood the technique?
Yes, sir.
So this is a generalized technique for any problem. Actually, in the homework, there were some difficult questions. You people did not ask the doubts, so I thought, okay, let me. Why should I take tension? आप लोग को पढ़ना नहीं है तो नहीं जाने दो. जिसको पढ़ना है पढ़ने दो. I left actually the idea, pressurizing somebody to study. जिसको पढ़ना है पढ़ेगा. जिसको नहीं पढ़ना है मत पढ़ो. I cannot sit here and pressurize you to study. I'm least bothered because it is beyond my control. So first and foremost thing, we have to write the equation of the line having x-intercept A and y-intercept B. And then you have to say, what is the meaning of family of lines? When does it become family of lines? How many lines are required for family of lines?
2.
Infinite number. Infinite numbers like locus. How many points makes a locus? Infinite points. Infinite number of points satisfying the same condition gives you a locus. Locus and family means the same thing. Here, set of lines, we call it family. Set of curves, we call it family of curves. Set of points, we call it as locus of points. So, what is the equation of a line whose x-intercept is A and y-intercept is B? Can you tell me?
X upon a plus y upon b equal to 1.
1. Very good. Now, when does this line become a family, when it become a set of lines, what should I vary to make it infinite number of lines? Tell me. If I
A
vary
and
x
B.
and y, okay. If I vary x and y, I'll get all points on the line. I will not get different lines. By varying A and B, we get all types of line. Do you agree with that? By changing different values of A and B, we get different lines. Do you agree with that? So what are the two things that I should vary to make it a family of lines? They are A and B. Therefore, A and B are the arbitrary constant. So how do you identify arbitrary constant? You should ask the question, what are the things, what are the letters or what are the variables that you need to change to get different lines? So here A and B changing, you get different lines. What happens if X and Y are changing?
We get different points on the
We'll get different points on the line. So A and B are the arbitrary constant. So how many times I'm allowed to differentiate?
2.
2 times. So how should I do? I want to remove this A and B. Tell me what I should do. Can I differentiate directly? I taught you 2 methods here. One method is differentiate directly. In the second step, make both A and B together as arbitrary constant and then differentiate again. So I can write like this. 1 by A into d by dx of x plus 1 by B into dy by dx equal to 0. Agreed? So 1 by A plus 1 by B into dy by dx is 0. What did I do? Differentiated with respect to x. Now I am allowed to differentiate once again. So make A and B on the other side. So what I can say, dy by dx equal to minus B by A. Again, differentiate with respect to x. So d2y by dx2 is d by dx of minus B by A. So d2y by dx2 gives you how much answer? 0, which is the required differential equation. Can you elaborate this geometrically? In a line, what is constant?
slope.
Slope is constant. So if you differentiate slope, what will happen? Rate of change of slope will become 0. So any line, any family of lines, will always find the second derivative will be 0, and that will give me the differential equation of it. Okay?
Yes, sir.
Yeah. Now write next question. I'm taking all questions from your book. Yeah. Let's understand that part. We know that if the vertex is at the origin and axis is along the x-axis, equation of parabola is, and lattice sectum is 4a, y square equal to 4ax will be the equation. Now we want the parabola whose axis is parallel to x-axis, which means something like this, parallel to x-axis. So naturally the parabola will be something like this. It will have same length of the lattice sectum as this. Only difference is its vertex will be some other place. So I can say the equation of this parabola, this red parabola will be y will become y minus k is 4a into x minus x. This will be the equation of the parabola. So what you can say from this? What you can say from this? What is the arbitrary constant here?
H and K.
H and K.
H and k. Why not 4a?
Because we
Leave the
need to
constant.
keep that constant.
Length of the lattice sectum is a fixed number. That don't have to vary. That means whatever the parabola I'm drawing, their shape will be same, but different. Like this, I can get one more parabola. I can get one more parabola, but every time this 4a is remaining same. So 4a is not varying. What is varying is the vertex. Therefore, h and k are the arbitrary constant. Did you understand this? 4a is not arbitrary constant because having length lattice of 4a, that is not changing. If this sentence was not there, then a, h, and k, all three would have been the arbitrary constant. So equation of parabola is y minus k the whole square is equal to 4a into x minus h, where h and k are the arbitrary constant. Now already h is independent of x, so first derivative h will go away. Second derivative will make a also independent of x, and you'll get the answer. Can you do yourself? Please do it yourself.
Yes.
So when you differentiate with respect to x, 2 into y minus k into derivative of y minus k is 4a into derivative of x minus h. I'm cutting some steps here. 2 into y minus k into dy by dx is 4a. This 2 gets cancelled. Now y minus k, k is the arbitrary constant. So we need to eliminate k. But what is the coefficient of k here? Dy by dx. So divide by dy by dx. So y minus k is 2a upon dy by dx. So what you can write next step? You can write y minus k is 2a into dy by dx raised to minus 1. Now differentiate with respect to x, you'll get your answer. So derivative of y, dy by dx. Derivative of k, 0. Derivative of 2 dy by dx raised to minus 1. Minus 1 dy by dx raised to minus 2 into second derivative of y. Now this goes to cross multiply with this and bring it to one side, and you get your answer. So I can write your answer as dy by dx minus 2a upon dy by dx the whole square into d2y by dx2. Therefore, dy by dx the whole cube is minus 2a into d2y by dx2. Now make it equal to 0. 2a into d2y by dx2 plus dy by dx the whole cube equal to 0. I hope you understood.
Yes, sir. Square upon a square plus y square upon b square equal to.
Yeah, the actual equation of ellipse is x square upon a square y square upon b square equal to 1. But then given whose major axis, which is 2a, is twice the minor axis. So a is 2b, which means instead of a, I can write 2b. So from this I can say x square upon 4y square upon 4b square is 1. So I can say x square plus 4y square is 4b square. Do you agree with what I've written?
Yes, sir.
This is the equation
Yes.
of the ellipse. How many arbitrary constant?
1. 1.
1. And how many times allowed to differentiate?
1.
And when you differentiate,
1.
will B go away?
B.
Yes, just directly differentiate, you got the answer. Two x plus 8y divided by dx equal to 0. X plus 4y divided by dx equal to 0 is the required differential equation. Tell me, what should be the equation of line which is parallel, any equation of line parallel to this?
X plus 3y plus
X
c
plus
equal to
3y
0.
equal to c equal.
Yeah, only the constant term will change. So equation of the line is 2x plus 3y plus c equal to 0. How many arbitrary constant?
1.
1. So how many times to differentiate?
1.
Once.
1.
So differentiate with respect to x. 2 plus 3 divided by dx equal to 0 is the required differential equation. Is it okay?
Yes, sir.
Now we'll do one difficult one. What will be the equation of the circle with the radius 9, center at h comma k?
Minus h.
X minus h the whole square plus y minus k the whole square equal to 9. So if you don't know coordinate geometry a bit, you cannot do these problems. You don't have to know everything, but somewhat you should know, at least whatever there in the textbook. So how many arbitrary constants are there?
2.
2. How will I eliminate h and k here? How will I eliminate? I am allowed to differentiate only twice. What you do is directly differentiate once. Come on, start with me. 2 into x minus h. There are many methods to do this, sir. Don't think only this method. Everybody understood what I did? Yes or no?
Yes, sir.
Yes, sir.
So from this, what I can say? X minus h plus y minus k. Or I'll do one thing. I'll change my method. From this, I can say x minus h can be written as minus y minus k into dy by dx. Right? So in place of this, I'll substitute this so that there'll be only one arbitrary constant. So I'm going to do that. This is 1. Substituting 2 in 1. So it became minus y minus k into dy by dx, the whole square, plus y minus k the whole square equal to 9. So y minus k the whole square became common. Now what to do? If I apply here, give me a product rule. I need to find y minus k. So apply the product rule here. I was thinking whether should I take it to the denominator. That also possible. If I do product rule, y minus k will be again there in the answer, but right hand side, okay. I'm going to do product rule. Now find the derivative of this. Derivative of this is, so I'm differentiating again with respect to x. My last chance to differentiate. I cannot differentiate after that. Y minus k the whole square into derivative of this. Okay, I'll write the steps. Plus dy by dx the whole square plus 1 into derivative of y minus k will be 2 into y minus k into dy by dx. I would have written 1 minute. To dy by dx of y minus k the whole square equal to 0. So this became y minus k the whole square 2 dy by dx into derivative of dy by dx plus dy by dx the whole square plus 1 into 2 y minus k into dy by dx. I told you this is a little complicated question. If I divide by y minus k, one power I can cancel off. I divided by y minus k. Now I'll make y minus k as a subject. So what will be here? 2 dy by dx into d2y by dx2. And this 2, okay, this 2 also will get cancelled. I divided by 2, so this 2 is not there. And this will be dy by dx the whole square plus 1 into dy by dx equal to 0. Now y minus k, I want to make it as subject, so I'll write this again on the next page. Y minus k into dy by dx into d2y by dx2 is equal to, this will go to the right hand side. Dy by dx the whole square plus 1 with a negative sign into dy by dx. So I can write y minus k is minus 1 plus dy by dx the whole square into dy by dx upon dy by dx. Such a 1 dy by dx also will get cancelled. Oh, that will be very easy to do. This is equation number 3. So we have to only eliminate y minus k from here. Where was our y minus k? Here. This I call it as equation number A. So just replace here, you will get the answer. Otherwise, yeah, this will do. This y minus k, if you remove from here, you will get your answer. So substituting in A. So minus 1 plus dy by dx the whole square into d square y by dx square. Y minus k the whole square is there. So square it. Then multiply with what? 1 plus dy by dx the whole square. Then equal to 9. Now when you square this, you will get 1 plus dy by dx the whole square into this. So cube is 9 d square y by dx square. Now make it equal to 0 and that becomes your answer. Okay. Have you written or not written?
1 minute, sir.
This part is over.
Yes.
Yes.
solution of differential equation. Usually this is the most important question, okay? First order differential equation. Your syllabus has only first order. We don't have second order differential equation. How to solve differential equation. That's what you're going to learn. Okay. So first time, I'll show you one problem. Solve the differential equation. Don't write anything, just listen. dy by dx is equal to 1 plus y square divided by 1 plus x square. This method which I'm going, there are different methods to solve a differential equation. The method which I'm going to teach you is variable separable method. Can you say something about this sentence, variable separable method? What does that mean? You know that when I want to differentiate, when I want to solve the differential equation, I got to integrate. But whenever I'm integrating, you remember, if I have dx here, the function got to be in x. If I have dy here, the function got to be in y, right? So what does this variable separable method says? Bring all dx, all x term with a dx, all y term with a dy and integrate. So what you have to do is, here dy, this y term, they both should be brought to one side. Here is a dx and here is x term. They both should be brought to one side. So I will write dy upon 1 plus y square is dx upon 1 plus x square. Did you understand this step?
Yes, sir.
Brought all y term with a dy, all x term with a dx. Then integrate. So integral 1 upon 1 plus y square into dy is equal to integral dx upon 1 plus x square. And when you integrate, you will get a constant. This is a small difference. In differential equation, the integral constant is written as soon as you put the integral sign. Whereas in indefinite integral, in the answer we put c. That is only just convention. There is no reason behind it. So tan inverse y is equal to tan inverse of x plus c. Did you understand this? Now, if you want to remove this tan inverse from here, it is possible to remove. I'm not sure whether your answer requires that way, but I'll just show you, just for your information. Suppose I want to remove this tan inverse. In that case, instead of writing tan in c, I will write tan inverse c. You are not asked to do this, but just for your information, I'm telling you. Then I will bring this 2 in one side. Tan inverse y minus tan inverse of x is tan inverse of c. Now I can combine this as tan inverse of y minus x upon 1 plus xy. Do you agree with this?
Yes, sir.
Now I'll remove off this tan inverse. So y minus x equal to c into 1 plus xy. And I can call this as a solution. This one way, but your textbook is doing only this much. Okay, this is just for your information I have written. If you write the integral constant also in tan inverse, then you can remove the tan inverse. For example, in your in JE, they may give you this as a solution. You'll be wondering, how did this became this? My answer is tan inverse, but this is an algebraic term which doesn't have any tan inverse. So this is how you can remove it. So just for your knowledge, I've done this. You can leave your answer is the general solution. If all the answers are tan inverse, constant also you write in tan inverse so that tan inverse can be removed in the final answer. Is it okay? Can you
Yes, sir.
can you write this one?
Yes, sir.
Heading variable separable method. Variable separable method. Then write this question. Solve. What did you do here? Bring all x with the dx, all x term with the dx. Dx should be numerator, and dy, all dy should be numerator. y with the dy. Then integrate. That's all to remember. So if you don't know how to integrate, you will get stuck. This topic is a little difficult unless you know all integration formulae. After you finish, you tell me.
That's it.
Done? Okay. Then I'm doing my next problem. Solve log of dy by dx is equal to 2x plus 3y. This is very common question in the board exam. What is the problem is you can't separate x with the dx and dy, y with the dy. Variable separable method cannot be applied with the log over here. So you need to remove this log. Can anybody tell me how to remove that log from there?
Take e raised to the power on the right hand
Yes.
side.
Log a to the base b is n. Then a should be equal to b to the power n. This you can apply. So dy by dx will be, what is the base of the log? When you don't write the base is e. Now tell me how I'll bring all x term with the dx and y term with the dy.
E raised to 2x into e raised to 3x.
A raised to m plus n is nothing but a raised to m into a raised to n. Therefore, dy by dx is equal to e raised to 2x into e raised to 3y. Now, all y term with the dy, all x term with the dx. Remember, dy and dx should be only in numerator. Don't bring it to denominator. Now integrate. Before integrating, you must check whether you know how to integrate it. E raised to minus 3y dy. Integral e raised to 2x dx. And here you have only choice of writing integral constant because you will not be able to remove e. So you will get, what is the integral of e raised to minus 3y? Nobody answer.
E raised to minus 3.
E raised to minus 3y upon
Minus
e raised to 2x upon 2 plus c is the general solution. If you feel like, you can bring them to one side. E raised to 2x upon 2 plus e raised to minus 3y upon 3. Even if you write here c1 and write it as c, where c is minus c1, because I interchanged position. So the constant here became c1, I wrote it to make my answer look beautiful. Always end up answer with a c. Here I wrote c1 because when I transfer, otherwise I should have written c1 over here. Remember that even if you write minus c, even if you write c, if you write 1 by c, all means the same, all are constants. Okay, one problem for you to do, so I'm not going to record that. Y is equal to x dy by dx. So dx got to be numerator. Now integrate. Yes, Sarah, correct. Very good. At least I come to know that you people are sincerely studying. That gives me a motivation. Shagun, right? Good. So log x is equal to log cy. Now remove log x equal to cy is the general solution. But remember, we have a habit of making y as a subject in a function. Even if you write y is equal to x upon c, y is equal to cx, all are correct answer. This is also correct. This is also correct. This is also correct. So all of them are correct because this C, 1 by C is a constant, so that can be taken as CS. So all of them are correct. Okay, so C can be anywhere. Even you could have written like this: log C plus log X is equal to log Y. In that case, you would have got log Cx is equal to log Y. In that case, you would have got Y equal to Cx. You would have got this answer. The difference between this and this is only differences. Here log C was written on the right hand side. Here log C is written on the left hand side. So accordingly, this will change. So you don't have to worry if the answer is given this way, even given this way, given this way, all means the same answer. Is that clear to everybody? This is a confusion. When you look at the solution behind, you will find that some format difference. But you have to only check whether you can bring your answer to the same format. Then your answer is correct. Okay, let's do one more problem. Sec square x into tan y divided by dx. Tan by dx, no dy. Only they are splitted and given in. Plus sec square y into tan x dy equal to 0. I would like you to try. Last time for me. So, okay, I'm divided by what terms I don't want? Cos x into sin x. When you divide by cos x into sin x, it is cos y upon sin y into dy minus
Sir,
sin, yeah,
why cos x?
cos x don't want here and sin y. Which term? These are all in y. इसमें x नहीं चाहिए. These are all in x. इसमें sin y नहीं चाहिए. So divide by जो नहीं चाहिए उससे divide करना है. So किससे divide करना है? Cos x से और sin y से. That means divide by cos x into sin y. When you do that, what will happen? देखो क्या हो जाता है when I divide. एक minute. It becomes cos x into cos y into dy divided by cos x into sin y minus sin x into sin y divided by cos x into sin y. So what happened? This will get cancelled. This will get cancelled. Now you can see denominator's derivative is numerator. So cos y, I don't have to write cot. Directly you can apply. All the time keep on checking whether denominator's derivative is numerator. That's the most common integration. And all the answers are in C. But here what happens is cos x derivative is minus sin x. So put a plus here and put a minus here. So now it is matching. So this became log sin y plus log cos x is equal to log c, which I can write log of sin y into cos x is equal to log c. Now remove the log. So my answer is cos x into sin y equal to c is the general solution. Did you understand the idea? I'll send you some more questions on the homework. Both, please try the homework and let me know. Okay, I'm stopping today with this much.